Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which I go through binomial expansions. So if you've forgotten, expansion means you start with an expression that has brackets, you end up with something that does not have brackets. So it became clear when we were doing equations that you're very good with expanding brackets using the distributive law. You know how to do stuff like this, x outside of x plus 2. We take the thing out of the brackets, distribute it to everything inside the brackets, and it's multiplying. So you go x times x, and then x times positive 2. That's easy as. For binomial expansions, now we're going to look at cases where you have two sets of brackets, and each bracket has two things inside. So let's say we have something like x plus 3 times by x plus 2. This is just an extension of the distributive law, which is what you use to expand brackets like these. So what I have to do is I have to distribute the 3 to everything inside the other brackets. I have to distribute the x to everything in the other brackets. You have to take everything in the first bracket and distribute it to everything in the second bracket. But that can get quite hard to follow, to try and remember where you're up to and keep track of it. So there is a way that, a method that we can use that will help you keep track of where you're up to, and it's called the FOIL method. So what you do is you multiply the first thing in each bracket, then the thing on the outside of each brackets, then thing inside each bracket, and then the thing that occurs last in both brackets. And if you follow that, you'll make sure that you've multiplied everything by everything else. So there are 4 things to do. So let's actually go ahead and do this example, x plus 3 multiplied by x plus 2. So first, the thing that's first in brackets, and we're timesing. Outside, so the x and the 2, the outsides in each bracket. So x times 2 is just 2x. Insides, so the two things insides. Sorry, that was FO, and this will be I. Insides, 3 times x. And then lasts, the thing that occurs last in both brackets. 3 times 2 is 6. Now, please make sure you don't make any silly mistakes with like terms. The only like terms in this expression are these two. 2x plus 3x equals 5x. It does not equal 5x squared. So to simplify this, x squared stays because it has no like terms. 2x plus 3x gives me 5x, and the 6 stays because it has no like terms. This is my final answer. Notice there are no brackets. Let's try it with a negative. Let's say we have x minus 1 times by x minus 4. We'll use the FOIL method again. Firsts, outsides. So this time it's x times minus 4, which is negative 4x. Insides is not 1 times x, it's negative 1 times x, which is negative x. And lasts is minus 1 times minus 4, which is positive 4. Again, these are the only like terms, so we get x squared minus 5x plus 4. How easy is that? So I'm just going to show you a couple of other examples that look different, but really we can use the FOIL method all the same. So what if I had something like x plus 3 all squared? Well, remember, squaring is the same as multiplying something by itself. So I can just write it in expanded form like this, and I do it no differently. Firsts, then the O is outsides, x times 3. Insides is also x times 3. And then lasts, 3 times 3 is 9. Again, these are the only like terms. I get x squared plus 6x plus 9. Please don't make this mistake. People, when they see something like this, they just square the first term, square the last term, and think they're all right. But they're missing the middle term. So you can't do that when you have a squared. You can't just square the x and square the 3. It does not work. So there are some times where you can use shortcuts. So let's say we have something like x minus 2 times x plus 2. We can use FOIL for that as well. So we go x times x, so firsts, outsides, so it's x times positive 2. Insides is negative 2 times x. And then lasts, minus 2 times positive 2 is minus 4. So minus 2x and positive 2x and negative 2x are like terms, and 2x minus 2x is 0. You're just left with x squared minus 4, because these middle terms cancel out. Now, that wasn't just a fluke. It's because this is what we call difference of two squares. A square minus another square, and the minus sign means difference. Difference of two squares. So when you have the same things in the brackets, except one bracket has a minus and one has a plus, you can take a shortcut. You just square the first term, square the second term, stick a minus in front of them. We couldn't use that shortcut here, but we can use it for the difference of two squares. So x minus 5, x plus 5. This will be the difference of two squares. They both have x and 5. One's a plus, one's a minus. Square the first term, square the second term, stick a minus in front. If you're not comfortable with that shortcut, you can use FOIL just like I did in the previous example, because FOIL is a method that will always work. But of course, we're going to build on this. We're going to use these ideas of expansion in factorizing and then solving quadratic equations and then graphing them. So it is important that we can do this quickly. Practice makes perfect. Hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.